Hello, everyone, and thank you so much for joining us in our chat about Zero Trust at Monzo.
Yeah, so a bit about ourselves to start with. I'm Liam. I'm a senior backend engineer and the tech lead of Monzo's staff security and detection squad.
And I'm Erik. I'm a TechOps solutions specialist in the TechOps team at Monzo. Before I move on, hands up for the people who know what Monzo is.
That's not bad.
That's a fair few. Very nice. But for those who don't know, Monzo is a bank in the UK and the US. We were founded in 2015 with a mission to make money work for everyone. We are a completely app-based bank and don't have any physical branches. Currently, we have 3,700-ish Monzonauts, day-to-day working on the product, customer support, making money work for everyone. More akin to what I do and what Liam do, we manage roughly 3,900 devices across 12 countries, and we have more joining every week.
Yeah, so we're here to talk to you today about how we rolled out Zero Trust access across Monzo. A few years back, actually stretching all the way back to 2019, we started having discussions about moving to a Zero Trust architecture. Ultimately, that brings us three main benefits. Previously, we were using a VPN to connect all of our internal tooling, and that is a nightmare for management. People moving around onto public Wi-Fi, different types of networks, it was creating a lot of inbound for our TechOps team. So we wanted to get rid of that and implement strong device identity controls instead. Secondly, we wanted to put users more in control of their own security using context-aware access checks, reducing the burden of large software updates on our TechOps team, but also giving that sense of responsibility to the end user. And then lastly, we wanted to introduce strong personal identity controls as well. So using things such as WebAuthn to reduce the impact of a phishing attack or a compromised device. The first thing that we focused on was how we rolled out device identity across the fleet. This is one of the most challenging parts, mainly because of the infrastructure that we used internally. For context, in our old environment, people's VPN profiles were exportable. This isn't great for a bank. I could just go in, take my production VPN profile, pop it on my personal machine, and we would be none the wiser. So we were looking at rolling out device identity, but we had a few challenges. Firstly, there was a lack of MDM support. So we don't use Active Directory internally. A lot of MDM providers at the time, back in 2021, 2022, before some changes that were made by Apple in 2023, didn't allow you to use dynamic SCEP challenges unless you were integrating with Active Directory certificate services, and that wasn't secure enough for us. So we needed to solve that problem firstly. Secondly, we needed a reliable trust anchor. So we didn't want an attacker to be able to issue a device identity certificate for a device that we didn't own. And at some point, we needed to say, we trust this thing to be able to issue those certificates, which is a bit weird in a talk about Zero Trust, but it will make sense going forward. And then lastly, we had no SCEP support in our PKI, which was the main accepted way of issuing certificates to devices back in 2022 when we first started this project. We use HashiCorp Vault internally, so we needed to solve for that problem and build out SCEP support on top of it. For those of you who are familiar with how SCEP works, you'll know that to secure these device identity requests through SCEP, the main thing that is available to you is this challenge parameter in your SCEP request. You can do two types of challenges. So number one is a static challenge, and that static challenge is just akin to a password that all devices will use to get their device identity certificate. A static challenge across all of our devices isn't amazing for security. If that challenge leaks, it's a payday for an attacker, and they can go and issue any certificate that they want. The second one is dynamic challenges, where generally your MDM will reach out to another system and say, give me a challenge for this device, and include that in the payload. The problem at that point was that our MDM didn't have support for that. So we went to Erik and the TechOps team with those words that every TechOps team wants to hear: we need to do an MDM migration.
That's right. A very exciting message from Liam's team coming across. But before we do talk about a migration, let's talk a little bit about our approach to MDM at Monzo. So at Monzo, in the TechOps team where I am, and we have Sam over there in the corner as well. We're quite a small team looking after quite a big company now. We're made up of 2 teams. We have a solutions team where I'm in. We're 4 people currently. And we have a support team of 6 people looking after day-to-day reactive inbound. This means that MDM and device management isn't necessarily our only focus. We look after many things across the company, office infrastructure, AV events, like what we're doing here today, SaaS applications, you name it. So we need some principles to live by to enable us to get the MDM done while also focusing elsewhere. So we like to automate things. We obviously make use of automated device enrollment, and we tie that in with our IDP so that we can get automated assignment through the enrollment journey and then do clever scoping based on that. We like pulling information between our identity provider, Okta, our asset tracking, and other systems around the company to make sure that we have as rich as possible of an image of the device, which further enables enrollment not only in the MDM but elsewhere as well. And for the more hardware-related stuff, the life cycle of a device, we like to integrate as much as possible there too. So for procurement, we do that all via API. We pull serial numbers, get webhooks back for assignment, pre-device enrollment. We also integrate with our repair vendors so that we can track the status of a device when it goes through being in repair, being ready for redeployment, etc. We move on to flexibility, where we like to try to achieve sort of a one-size-fits-all for all devices at Monzo, and we've nearly made it. Currently, we discriminate or we separate customer operations and everyone else. The baseline configuration is the same, but there are some minor tweaks in between the configuration profiles going out. This just ultimately allows us to have a nice known base to troubleshoot when things go wrong. We also like to lean into best tool for the job. So if you were to take a look at a Monzo Mac, you will find a lot of open source software from the amazing Mac admin community. To name a few, you will find Swift Dialog, Monkey, DocuTill, Desktopper, Nudge on there. We really enjoy being able to have those on our devices and contribute back where we can. Ultimately, this allows us to stay agile, and with so many systems and tools in place, we like to connect the dots where we can, leveraging the information we can gather from all the different utilities to make as good a user experience as possible. So how did we get here? Well, Monzo was founded in 2015. By 2017, the sort of startup vibe approach of the engineer will have an admin password for you, non-engineer, who are a standard admin, didn't scale anymore. So Monzo moved on to Fleetsmith. Fleetsmith was with us for a fair few years, up until 2020, and it saw us through hyperscaling. So it worked quite well until one day, roughly halfway through 2020, when it all of a sudden didn't work so well anymore, and we had to change. And this is when Monkey came into Monzo. We decided to move our package management across to Monkey, which allowed for automation, but also kept package management separate from the MDM, enabling us to stay stable. Or agile, sorry. In the first half of 22, the Zero Trust plan was fully formed, and along with it came the need to change MDM. And by November 22, we had completed the migration and rolled out the first iteration of device identity to our laptops. So, the migration bit. Due to various factors, in and outside of our control, we ended up with about 2 months to fully configure Jamf Pro from scratch and move all 2,500 devices at a time across to Jamf. We wanted to facilitate a smooth move, of course, and make it have as little business impact as possible. So it was quite a fun no-go meeting to be part in, but ultimately we said, yes, let's do it. And we did all 2,500 devices in just shy of 3 weeks with minimum impact to the business. Touching briefly on how we did that technically, we did a like-for-like migration. We looked at our previous MDM, copied essentially all the config in there over to Jamf, so we didn't introduce any new variabilities into the migration itself and the experience. We worked quite closely with Jamf and used Jamf Migrate for macOS. And here I want to give a shout out to Andrew Needham and the Jamf team for much help from them seeing us through. And lastly, we had a few separate independent data sources, allowing us to keep track of devices as they were traveling through the migration. identifying potential stragglers or people who got stuck halfway through. We wanted to have that comfort in additional data since we were going to need to do quite large batches to get through all of them in one go. Technology will only take us so far, though, and we needed engagement from Monzonauts to be able to see this through. And this is where HotChip enters the picture. HotChip is a plushie and our internal mascot, and it's a very rare commodity at Monzo. The only surefire way to get a HotChip plushie is to have a child, which is quite the commitment. We, however, managed to secure one through some back channels, and we decided to run a raffle. And this is where the most important bit of our migration comes in, communication. So we engaged, well, as I'm sure most of you have experienced, you can have all the tech in the world, but you actually need people to go push a button. And to do that, we need to engage with them and nudge them along. So we went to Slack, Monzo's main communication platform, where everyone at Monzo is familiar with. We know where to look for announcements, etc. We led with the incentive. We did a raffle. If you migrated within the first 2 weeks of the migration, you were entered into the raffle, and we would pick at random anyone in that pool of people who could win the plushie. We engaged with leadership across the business, especially in business-critical roles, to allow for customer operations, for example, to have time set aside to be able to complete the migration, as well as engage with the people team for people on long-term leave, etc., understanding, could we approach them, could we not? Making sure that we considered all the variabilities. We did our migration in a 3-step approach. The first bit, the raffle bit, that was self-service volunteer. People could go into a self-service app, click start, and see itself or see it through themselves. We then targeted groups within the company and nudged them along. And ultimately, when we were close to the deadline, which was quite a hard deadline because we had to leave our old MDM, we just set it going for everyone else. Here's an example of what our announcement post to the company looked like when we kicked the migration off. As you can see, we lead with the plushie, and then we talk about the MDM migration later, the most important bit at the top, as always. And we further used our laptop security bot, which is a Slack bot plugged into our backend, OSQuery on the device. We'll look at the MDM profile, compare it to the assigned user in our backend. If they doesn't match what we want them to, send them a Slack message and ask them to complete the migration. And ultimately, as you saw in the graph earlier, we had quite good uptake from that. So that's how we got the MDM support in place. Now on to how we make sure it's all safe on the internet.
Yeah, so thanks to Erik and the TechOps team, we now had support for those dynamic challenges through the SCEP proxy functionality of Jamf Pro. This ultimately means that we can issue a different challenge for every device, really simply. When Jamf is about to push the SCEP profile to a macOS machine, they send a webhook to Monzo's backend, and that goes through an API infrastructure to start with to receive that from Jamf before we run an asset inventory check. As Erik mentioned before, we're probably in the privileged position that our device providers integrate with us through API and webhook. So when something is dispatched, we get the serial number and where that is going before the device actually leaves the vendor. We also get the tracking number as well for the device so we can keep an eye on it as it moves through that delivery journey. So we check, is the laptop that is in Jamf actually a Monzo-owned machine, or has someone managed to get a device into Jamf through whatever means? Once that check passes, we then issue a challenge to that device. This challenge takes the form of a JSON web token. If you're not familiar with the JSON web token, this is essentially a cryptographically verifiable password containing some data. So the data that we include in our JSON web token, as you can see here, is an asset ID, and that's our internal asset identifier for that device, and also an expiry time. These challenges can only be used once. Once they're used, they are invalidated, and they can't be used past the expiry time. So once that device checks in and requests a certificate through this flow, that challenge cannot be used again should an attacker get hold of it. Ultimately, when the device then checks in to get a certificate, it goes through this flow. So firstly, it enters our SCEP API service, and the reason for having this separate from the actual issuance flow is that when it comes to support things like the new Acme functionality in macOS, we only need to replace this layer. We don't need to do everything else below. We just need to be able to convert that Acme request into something that our backend infrastructure can understand. We can support both if we need to support multiple OSs, which is a huge benefit for us. The SCEP service then passes that on to our internal device identity services where that challenge is verified. If the challenge has already been used or it's expired, we'll reject the request and send that back to the device. If the challenge is valid, we pass the certificate signing request onto HashiCorp Vault through the PKI API, where it then signs a certificate for us and returns that back to the device for it to be installed. As a side note, if you're interested on how Monzo does PKI, there's a really good blog post on the Monzo blog that's called How We Protect Our Most Sensitive Secrets from the Most Determined Attackers. You can visit the URL there, or there's a shortcut. If you just Google Monzo PKI, it's the top result. So yeah, we have success. We have a client certificate installed on the device. So step one is done. We're now able to use MTLS to authenticate access to our internal applications using this. There's some data inside this certificate, mainly in the URI field in the form of a spiffy URL that contains things like the operating system of the device and the serial number, which we're then able to parse out and identify. As a side note, you're probably all thinking, why are you not using this? This is not around at the time. This is a much better implementation from Apple using the secure enclave to sign challenges and being able to verify them through an Acme challenge. So go and read up about this if you're looking to do this separately. There are some shortcomings to it, mainly that third-party apps can't yet use those certificates, but we're hoping that that may change shortly. Cool, so we'd solved device identity, and it was now on to user identity. For context, before we did the Zero Trust rollout, we were using Duo for 2FA into our VPN. Duo, a much better user experience for us than requiring a 6-digit code to access our VPN, although it leads to some possible phishing attacks. Basically, you can have MFA fatigue if an attacker keeps constantly spamming you with push notifications. It only takes the user to press approve on the wrong push notification, not look at the request closely enough for us to have a problem. And we really wanted to solve that with the new Zero Trust implementation.
Additionally, Duo, if you get locked out, if you have a new phone, if your phone breaks, we have a process in place that would create quite a lot of inbound just to make sure that we stayed safe, but also enable people to work. So having Duo reset up on your device or unblocked required a one-to-one video call or in-person chat with someone in our support team for identity verification purposes, which took quite a lot of time, especially around mid-September when a company in this room releases new phones. That saw quite a significant increase in inbound requests. Yeah, so to solve this, we turned to our identity provider, Okta, and Okta Verify, as well as WebAuthn. So thanks to Okta Verify, we're able to use the device identity certificates that we previously pushed as a possession factor, and also prompt the user for Touch ID before they authorize the request. Rolling this out has already stopped at least two attempted phishing attacks. They weren't successful, thanks to Okta Verify. Those involved essentially a man-in-the-middle proxy between our Okta login page and a phishing email. So it linked through to an unknown URL and then presented the user with what was, at the time, our genuine Okta login page, but those requests were being attacker-in-the-middle, which isn't ideal, but Okta Verify stopped those in their tracks. The user never saw any password prompts. They were just returned an error message immediately. So if you do have Okta, take a look at Okta Verify. It is a very, very good way of doing 2FA. So on to context-aware access, piece of the puzzle in our Zero Trust journey. Before we do dig into what piece of information we look into, let's have a quick look at what tools you may find, again, on a Monzo Mac that help us get there. So we do like to try to use the best tools there is available to us. And beyond our MDM, here are some of the software pieces that you will find on our Macs. It's not an exhaustive list, but it's some of the ones that are worth mentioning. Monkey is core to our operations, as I alluded to previously. It's the first package that we deploy during laptop enrollment. And it will do all of the heavy lifting for us during that journey. It also gives us quite a lot of nice data we can look into to feed into the context-aware access piece. We then have OSQuery and Fleet to stay in touch with the device and be able to find out really quite granular information if we want to. And this is quite helpful for the contextual access story, but also a favorite of our SecOps team, who build reporting and alerts around this. We leverage Slack, as I touched on previously, to message Monzonauts. The security bot that you saw previously has additional functionality beyond an MDM migration. We look for example, does someone have a 1Password recovery kit stored locally? Let's message them about that and ask them to get rid of it. Has someone exported data from BigQuery and has it sitting on there? Really shouldn't be there for much longer than you need it, so let's message them and let them know that you better get rid of that information when you're done with it. Lastly, and probably the bit of a rogue one here, is GitHub Actions, but it's critical or core to how we run Monkey, namely all of Monkey is running GitHub Actions at Monzo. We run Autopackager in GitHub Actions, I should say. That will take care of the whole package pipeline. And it gives us a pull-based or a pull request-based approval process for packages as we get updates in. So Autopackager will run, check for new versions. When it finds anything, it will open a pull request for us, as well as putting it into our testing repo with the testing manifest. So we can have testing max ready to go as soon as the PR is open. When we've tested it out, we approve and merge the change. That will then move it all into the production repo, which will ultimately reach the laptops in short order. This keeps everything in the cloud, which is very nice. We don't need to look after a Mac Mini or other server in a closet somewhere, and allows us to stay agile and have it all in version control for free, which is very nice. It also enables us to keep it separate from the MDM, which means that you can move MDM quite quickly and quite easily if you need to.
Yeah, so Erik's walked you through how we do device management and some key parts of our setup. Ultimately, though, Zero Trust Access is about admitting that MDM can and does go wrong despite how well you have it set up. You can have all the automation in the world, things can and do go wrong at times. And it's up to contextual access to identify those cases and prevent users from accessing data that they really shouldn't be while that misconfiguration exists. We run a number of context-aware access checks. This list isn't exhaustive, but we check for things like, are there any open CrowdStrike alerts for this laptop? Rather, probably expectedly, is your macOS up to date? Is File Vault enabled? But we also throw in some things like, are you actually running inside your Monzo managed Chrome session? So are you signed into Chrome? Are we running, does the configuration that we exist within Chrome? Also, for internal fraud, which is really good, like is the user who's logged into our internal tooling actually assigned the laptop, or have they compromised another employee's credentials and are doing something nefarious with them? So yeah, not exhaustive, but this is an example of the type of things that we're running. Although running all of those checks on some web apps is actually detrimental to the user experience, so we don't run them all for some of our web applications. For example, we have an internal build of the Monzo website running behind context-aware access and our Zero Trust infrastructure, so web engineers can test how things operate on different devices. Enforcing that people are operating in a managed Chrome session while they're doing that actually stops them from doing their job. They can't go ahead and test how does that operate on Safari, how does it work on an iPhone, because we actively try to prevent that with some of these context-aware access checks. Although those checks do make sense when you're accessing our internal tooling that contains customer data. We want to make sure that you have all of the configuration that we expect on that device, and you're accessing it how we expect as well. So we run those different tiers. A couple of examples in each of those, like we have our internal office map in our low-risk applications, any application that contains customer data in the high-risk section. One thing I am going to point out here is that top box. If you put your either Google Santa Sync server, OSQuery TLS server behind your Zero Trust or your device identity rollout, make sure that you don't apply your context-aware access checks that rely on that data to those. Speaking from experience in our staging environment, it really doesn't end well. So we run all of these checks, but one thing I wanted to point out here, as you've probably seen from the list that we run, we don't believe that on-device agents are enough for evaluating context-aware access, and that seems to be an industry trend as well. There are a number of things that could happen. We really love OSQuery, and we make use of it internally. The network could be blocking those requests for whatever reason. An attacker could be modifying them and submitting that data back to your server. So although things like we run Google Santa, the Santa system extension may be running, we also actively check on our back end when a request was last received from that device to our sync server. The same with CrowdStrike. We don't just trust that the CrowdStrike system extension is running, we also check with CrowdStrike when it last received a response from that machine. We have seen cases where although the system extension is running for CrowdStrike, that machine isn't checking in with the cloud whatsoever, and we've got no visibility over it. So these checks help us prevent that. So things that you might want to think about here, like are you checking in with your EDR to check that that device is healthy? Has it been checking in? Are you checking in with your device management provider? Although there is an MDM profile on the device, we've seen times where Jamf no longer believes that it has a management channel, and this helps us prevent devices that we don't have any control over at that point from actually checking in to our internal tooling. Software update tooling, so we integrate with Monkey and our vulnerability management tooling to check if people have software updates pending for longer than a week and then start prompting them to update if we require a restart for some applications. But lastly, there is a treasure trove of information inside the actual HTTP request to your internal applications. Things like, is the network that request originated from trusted? Could it be a Tor endpoint that would be indicative of an attacker accessing our internal tooling? Or is it coming from a suspicious browser? Something like that. So I think that's what we're trying to get at here, is on-device agents are great. We love OSQuery, but what else can you augment from the other data sources that have available to you? I think that's also a shout to the vendors in the room as well. If you have a product where we cannot get your data from an API and programmatically read it for context-aware access checks, it might be time to start thinking if you need to implement that, because the industry is moving this way. We've seen it with things like the new Google Enterprise connectors in Google Workspace, and also Okta Device Trust as well. So we run all of these checks, but the key thing is that you need to be clear to your users when things go wrong and that you're actively blocking them. We show this help page to people to walk them through what we need them to do. Example of this one, which is you've got pending updates in the Monzo App Store, which is our Monkey implementation. We tell you what you need to do, but the link on this page deep links you straight into the Monkey updates page. So all you need to do is click that link, close any applications that Monkey says is currently blocking you from performing those updates, do the updates, reload, and you're back in immediately. There are some checks that maybe require a bit more remediation from the user. It could be that like your 1Password recovery kit is sat on your disk somewhere, and we want you to go and remove it. We can link you into a Notion page which contains screenshots on how to remediate some of these checks as well. Ultimately, your users can be your biggest asset when helping you to secure machines or correct configuration. So communicate with them, be as clear as possible on how they can fix the problem and get back to working immediately. Although another thing to ask yourself is, could this just be fixed later? So if you need to perform a macOS update, a bit like some of the things that Apple showed us previously, can you give them a grace period? Do you really need to enforce that update immediately and stop that person from working? That is a great way to remove goodwill between your IT team and your security team and the rest of the business. Can you give people like a 2-week period to do that update before blocking them? We show this screen to people if we have something that will block you in the future. We show that screen to people once every day. We enforce that using a cookie on our internal infrastructure. If you don't need to enforce that for people, don't block them from working, because that is a great way to just get everyone angry at you. But if you get it right, the upsides are huge. So the top graph that we have here shows our support requests. You can see that when our Zero Trust Access implementation went live in September, we've started since then tailing off on the number of support requests that our TechOps team manage day to day. But not only that, we've seen an increase in the number of devices that actually remain up to date at any one time. So, like I say, your users are your biggest asset here. If you're clear with them, those error pages guide them through what they need to do. A Zero Trust rollout can be super impactful for you.
So to recap a little bit of the timeline, in July 22, we moved 2,500 devices to Jamf without significant business impact. November 22, we had the first first version of device identity on Macs and going, and shortly thereafter in Jan 23, it was a 2-week sprint to enable or to build the MTLS architecture. And we started this with quite a safe app internally to try out what would eventually become VPN-less. Our office map is a very low risk to give people access to the floor plan. However, it's very nice for people in the office to just be able to get to it straight away, not having to connect to VPN when they're trying to find a meeting rooms 2 minutes into the meeting.
Yeah, and then in April 2023, we took advantage of our new device identity implementation to move Google Santa away from what was essentially serial number-based auth to certificate-based auth. So there's also improvements there that you can make with the device identity rollout. Before, in September 23, actually moving over our customer support tooling and getting the majority of the organization onto Zero Trust Access. You can tell here by the number of emoji reactions, it's in the region of about 250 for one of those emojis, that people at Monzo loved not having to use the VPN anymore. And then finally, in the next few months, we'll migrate Monzo's remaining developer tooling over to Zero Trust Access. There will be some that needs to remain still behind a VPN, but they will be few and far between. And at that point, this rollout will be finished.
So how did we do this? Well, at Monzo, security and TechOps, we sit within the security collective. So that means we're literally neighboring desk banks. We work every day together to make the user experience as amazing as possible, while also making sure that we keep the bank safe. And if you would like to help make the bank safe, we're hiring. We have positions open in the TechOps team, where I am at, as well as in engineering at Monzo. If you want to find out more, go to monzo.com/careers, or come find us around the conference. We're wearing these lovely hot coral lanyards.
Yeah, so thanks everyone for listening. If you have any questions, feel free to ask them through the Hoover app. Erik and I are also both on the Mac Admin Slack, so feel free to send us a DM, or, as Erik said, find us in person. Failing that, it would be amiss if we didn't call out. We're both on LinkedIn as well.
Thank you very much.
Thank you.
Just before we move on to our next session, whilst I don't see any questions in the Hoover app now, myself and Alex are available on these microphones if you have any questions. Whilst we've got a couple of minutes left, does anyone from the audience have a question for the Monzo team?
That's normally a good sign.
It seems to have been very clear.
I would say that's a very good sign. So if you wouldn't mind joining me in one final round of applause for the Monzo team. Thank you very much.